All right, so let's go ahead and continue working with our image detection and image analysis in Mathematica. So specifically, let's look at how we can detect morphological features in a system and edge detection. So lots of times when we're working with images, we want to measure things. We want to look and pull out these, for example, these dots, these magnetic particles, these beads. So one of the things you can look in a system is look for edges. So you could do edge detect. So it detects essentially edge detect. It detects the edges in your system. Ooh, that was for some reason difficult to say. And you can look at the Mathematica or look at the syntax in Mathematica, and you can kind of see. So you could find edges essentially at specific scales or thresholds, or so you can kind of look deeper into these options. So you can specify, for example, a radius of certain ones. You can look at, again, straight edges or methods effectively. So it's always good to kind of look at these options and see what's possible. So see, as we look for a larger radius where we're cutting out some of those images, you could look at even very specific thresholds and methods, and change essentially those methods as well. So you could look at straight edges, or there's tons and tons and tons of ways that you can kind of look at this. So for example, let's play around with this code for just a little bit. So I could do radius 1. How about, what happens if I do radius 10? So see, I'm starting to filter out kind of those uglier ones. So about radius 20. So now, again, it starts to get a little ugly effectively. I could do 1 and I could do 0.2 features. What about 1? About 0.1. So again, you'll have to play around with these values and see where you can go, where you can get off to, and you can kind of see these edges. You could do edge detective Einstein, and again, you could try to maybe, let's see, I wonder if we could clean this up a little bit more. That's a nice one. So again, play around with it. Image detect here. That's a nice. Again, you can kind of see bigger features. That's a little bit, it's more like a Van Gogh. Ooh, that was a bad joke. Anyways, so I could do edge detection after I do, essentially I could do other functions. So I could binarize my image. So for example, if I binarize, it's just changing everything to black and white. I could binarize at a certain, percent binarize, or basically pixel value binarize. I could color negate. So if I do color negate, I can go ahead and take this function here, and it's just going to switch. Black is white, white is black, etc., etc., etc. When you're measuring values, you usually measure on the black background, and you measure the white components on the screen. So that's typically how Mathematica works. So you could do edge detect here. You could look at morphological components, and you could actually color the different morphological components. So you could find distinct components. So here, we're looking at the distinct morphological components that have different, radii, different values here. You could do the same thing for, again, Einstein, binarize. Let's see if we can do 0.1. Ooh, 0.8. Get the values. You could change those. Again, same thing for our image of our girl. We could look at clustering components as well. So morphological components, we can look at components of the images that are clustering together. Here's a good example where here we're letting the image essentially decide the different clustering components. You see, actually, it takes quite a while to run that subset of code. So it's looking through all the features of the images, and then it's setting the color. I could set 2 types of components. So I could set, see, it's going to be all here or all here. So it's detecting essentially what are the components in the image. This is a nice one because now I could change essentially what I'm searching for from black and white to just, or actually clustering components. You can see clearly my particles here. So it may be easier now, here you can colorize. Maybe I could do color, or actually I could binarize now. Or you could actually effectively measure the components here. As you start to kind of add these different components in here, oops. Ooh. Thinking. This doesn't make for the most exciting YouTube video, but again, just trying to play with it. Again, if it's starting to take too long, you could just evaluation abort the kernel, or abort evaluation. I could remove the background. and it will try to find, basically identify what the background is. And you could play around with that and remove background in order to kind of see. Actually, we can look at it. Remove background. We can see what we have at our disposal here. So see, if we have a nice clean image, it'll kind of try to find those. You could specify green and all those things. Actually, we'll see that in just a second. So removing the background here for our image worked really well. It'll work better actually if I do brightness equalize image, for example, then remove background. But you see this image processing a lot cleaner. This is really, really, really nice. That brightness equalize is a very nice function. But you see, it takes a while when you start to kind of nest these different functions together in image analysis. Image analysis takes a while. It's very RAM intensive, hence why I'm going to save my notebook right now. So I could specify a color to remove. So I could say, all right, remove, once I save. See? When you have all these images in your notebook can get really, really, really large in terms of the size of the file. So be careful about that. I could remove black. I could remove green. I could remove black. Actually, we already did black. I could do yellow. So we can move that yellow flower. I could remove blue. Not really any blues there. Red. Let's see. Yeah, a little bit of red there. The nice one is obviously with this example. This nice clean green. Also, you can look at what it would be like if you were a dog. So you can look at how is the image looking like if it is colorblind. So color blindness, you'd see how it would look like and how the different values. So actually you can look at yourself, there's also value, you can kind of put yourself how it would look like if you were a dog as well. So play around with that image effect. Image effect is actually a very fun function as well. So after this, you've kind of seen some of the different kind of ways we could make measurements in images. Next time, we're going to get deeper into this, start to take measurements after we do all these binarizing and color negating, and then we can kind of look at a practical example of sickle cells and then non-sickle cells. All right, I'll see you all next time. Thanks.